Bevy Jam 7 is over, and I contributed a submission, at least. This is the first level in the dev build, so I figured I would show off what the game does, talk a little bit about what my week looked like for the Bevy Jam, and cover a couple of the pieces of functionality that I feel are interesting. I'll cover a couple of the crates that I ended up using, as well as kind of describing where my effort went, and showing a few of the tools that I used like Blender. So here we can see the dev build. I'm going to get rid of Bevy Inspector eGUI up in the top left with escape. There's a couple of dev tools. We might talk about multiple cameras later. I ended up using Bevy's fly cam for some development, but I also ran into some issues with it. The player model is animated. These animations are built in Blender, exported to GLTF, and then initialized through a custom GLTF extension handler, which we'll cover later. That builds the animation graph with all the animations and so on. So this being the tutorial level, you can see the controls are WASD, so you can move forward and backward. And unfortunately, there is a hammer slam here with some effects on it, but I forgot to, or actually I ran out of time for a bunch of stuff. One of the things I ran out of time for is actually continuing the animation that I had for the idle animation in between the hammers. So unfortunately, the idle animation only plays at the very beginning. And once you hammer, you are T-posing for the rest of the game. I said WASD gets you into this glowing area, which is a custom material. And then we get into a little bit of spawning. So this is the second tutorial level, another bit of text on the level, and a enemy that just spawned in with a little attack that I'm going to wait for. And then you can see the health bar actually showing up. This is a fairly light enemy. It actually just hit me, so I took some damage as well here. And then once that is destroyed, you can exit, and the sort of interior energy area here, portal, whatever you want to call it, becomes available. So this is the full level at the basically the end of the game, with a bunch of different enemies in it. Actually, a bunch is maybe a little bit of overkill. There's the eyes, there's the little like Star Wars droidy things, and then there's also gem towers, which haven't shown up yet. So you just smack the hammer on these, and I think I'm most happy with the spawning mechanics here, as well as the texturing for the actual enemies. So if I go in here, it'll bump the number of enemies, and this is basically just wave-based at this point. So the towers have their own shaders on them. The health is a little bit too high. I think up at like 200 or something. I think the hammer is doing something like 20 damage. So the player controller and the like attacks and stuff are something that I really didn't really get to before the jam kind of ran out of time here. So again, you destroy the enemies. There's a couple of effects. There's a couple of shaders here for the energy well below the crystals. And if you destroy them all, you get to leave. You can see that there's a whole bunch of stuff that's untextured here, like the base plane is still using my blockout texture. There are enemies, but they like don't have an awareness system on them, so they don't really know that I'm hitting them, which is something that I also didn't have time for. I have like a half-built awareness system. But other than that, it's got some things that I'm happy with. I'm happy with, again, the spawning effects that came in, and the character itself, the animations for the hammer, as well as the actual like game mechanics, I guess you could say, are things that I kind of like didn't end up getting time for. So that brings us to the code. I guess we'll start off by closing out a bunch of these files and talking about it from the top. One of the things that I really wanted to get to in the jam but didn't end up having time for is I wanted to make some of my own audio. I wanted to record my own audio and make my own sound effects. So the whole setup for my Cargo Tommel uses Bevy 0.18. Default features false, with the intent of removing Bevy audio and using Bevy seedling, which you can see in the dependency list here. I didn't end up getting around to that, but it's there to use. For input, I'm using Bevy enhanced input. I did end up, I think, finding a bug in one of the components in Bevy enhanced input, which I've opened an issue for. Hopefully that will get fixed. But there are also workarounds. Bevy Inspector eGUI we just looked at. If we bring up that menu again, you can see basically everything in here that has ever spawned. For example, here's some of the crystal pylons. I can go into the children entities, see what components are on them. There's a gem at the top, a gem holder, which is that kind of like animated effect. The energy interior is that bright area inside of the base. And then the cylinder, I guess I didn't name this in Blender. So it's just called cylinder instead of like stone or something. Bevy Inspector eGUI is very cool, very useful, especially if you are kind of unfamiliar with like what entities are and where components go and things like that. I did bring in noise as well as Bevy Skeen. Bevy Skeen, obviously, for the Blender support. I was using a fork that I was working on for the Jam with GLTF extension support. So if I look at my GLTF file, this is going to look a little bit messy, I think. But you can see in the extensions field on all of these nodes, this is an empty that I have a player spawn location on. This is the nav mesh that I was using with visibility hidden because it's a nav mesh, you know. I've got a couple of components for swapping out materials as they come in and spawn. Not Shadowcaster, not Shadow Receiver, some built-in components and stuff like that. So this extensions approach means that all of the components are actually inserted while the GLTF loader is loading the GLTF file. So when this node gets transformed into an entity in the GLTF loader, that is also when these components get inserted. This is a slight difference if you're using Bevy Skeen on main right now, which uses GLTF extras and is basically observer hook based. There's a bunch of rand crates here: noise, rand, Bevy rand. Bevy rand is very, very cool. I like Bevy rand a lot. We'll talk a little bit about using Bevy rand and what I used it for, but Bevy rand is very, very nice. Bevy blockout is that texture on this plane here. So this is just getting applied. It's a triplanar texture. This is only 2D, so it is what it is. We don't really see any of the triplanar aspect of it, but this does mean like, here's a 1x1 square in the world. So I do get to see like this gem is basically 1x1 on the XY plane and is quite tall. Bevy Shader Utils is another crate of mine that has some like Perlin noise inside of shaders and stuff like that. Nice to not just copy and paste all of my Perlin noise implementations and stuff. Bevy Asset Loader with IES Progress are used for making sure that this GLTF data and whatever other assets I used are loaded before the game actually starts, which is useful for spawning in levels and things like that. And then I think the only other relevant crate is Vlu Navigator, which I quite like. Vlu Navigator is a nav mesh crate. I don't really show it off all that well, but all of the spawning here is basically sampling from the nav mesh and then picking points on the nav mesh that we can't see to actually show. Let's see if I can actually bring this up. So I'll search for nav mesh, check the visibility on the child. So here, visibility hidden. If I turn this to visible, this might not actually have a material on it. Hang on. Children, nav mesh, transform, and then I bring it up a little bit. You can see that it was just kind of like sitting right below the actual plane. So this is our actual nav mesh in the game, or the mesh that we use to build the nav mesh. The nav mesh actually gets constructed by Vlu Navigator and is an asset separate from this nav mesh. But this nav mesh defines where all of these enemies can spawn and where they can go. So when we use Bevy rand to sample a new position for these to go to, they are sampling it from this nav mesh. There's probably a few things that I think are interesting. Just starting at the main lib split is probably interesting enough. I don't really put that many things in main. I use main as the entry point to the binary. There might be, like if I had some CLI configuration or parsing that might go in here, but everything basically is in lib for me in this function that returns an app. So this app builds my entire Bevy application. I've got fit canvas to parent, so in full screen, this fills the whole screen. And a couple of cargo features for things like the Bevy Inspector eGUI in the dev build, as well as free camera. I chose to build the project off of the base of Bevy New 2D from the Bevy Flock organization, because that makes it so that I can help other people who are having issues. If they run into things during the jam, I will also run into them during the jam for the most part. So Inspector eGUI is a feature that turns on Bevy Inspector eGUI as a dependency. FreeCam turns on Bevy's FreeCam feature. And that just sits in dev and dev native alongside file watcher and embedded watcher and things like that. These watchers are really interesting because if you're working on shaders, they will hot reload. If you export a GLTF from Blender, it will hot reload. I kind of keep all of my third-party plugins in one area and all of my plugins in a different area. So all of these plugins come from some crate, and all of these plugins come from my application. While we're doing this loading, there is a GLTF extension that I built here, which is kind of cool. This has an observer to play an animation by default after we construct the animation graph and stuff. Has some component information and things like that. And then we have a GLTF extension handler implementation that pulls in all of the named animations and the routes that get the animation player. And then when a scene is finished loading, goes through some of that stuff. In this case, it's just checking for player, so it's not really super generic, but it builds that animation graph from the relevant clips while the GLTF is loading, makes that animation graph a sub-asset of the GLTF file, and then inserts that onto the root entity with the animation player. So when we spawn the scene, all I need to do is go through any of the descendants of the scene. In this case, we would be spawning the player scene, grab the animation player and just play whatever animation I want to play. I built a little utility function on this component so that I can pass in the animation by name instead of by ID or index or anything like that, because I call it idle. I don't know what index it's going to be. This is something that I'm hoping to generalize a little bit and build into Skeen, which brings me to some of the other animation stuff. So we're using Bevy Asset Loader, and we have two states in the game. We have an initial state, which is just asset loading, and then a playing state. Very sort of simple in that respect. I didn't get around to implementing pause menus or anything like that, so there's no other like additional states. When we go from loading to having loaded, when we exit the loading state, this actually fires, and I add events to the actual animation clips in the graph. So in this case, I'm looking for Hammer Slam, which is the attack animation. I'm adding an event to fire at 0.37 seconds into the animation, as well as the full duration. There's a finished event. So I get rid of that nav mesh here. You can see this animation that's plays, and then there's this effect that happens when the hammer hits the ground, but that's before the animation actually finishes. That's the event firing. So that's this Hammer Slam hit, which I don't think I handle here. I think I handle it in a different file. Saturday and Sunday were a whirlwind of throwing code in random places. So I do have to go back and kind of clean up a lot of this. But you can see we've got a material for that hammer smack effect. It's got an alpha mode. It's got a WGSL file. When that event fires, it's an observer. So when the hammer hits the ground, I do a bunch of stuff, pick a location, build a mesh from that circle, apply the material, and then do some calculations to determine whether the enemies around intersect with the hammer hit area. This is all done built into Bevy. So I'm using bounding circle and AABB 2D. This is 3D visuals, but the collision is all 2D. So all of the, I don't have gizmos built for the collisions, unfortunately, so I can't show that. But the lasers that are coming out from these little black balls, as well as the eyeballs, I didn't get around to actually building effects for them, but they are currently raycasts that collide with the player, but only on the sort of XZ plane. Similar things for the end gates. The end gates are these things that turn on later up in the top corner. Those are done with AABB 2Ds. Calculate the global transform, figure out if the player intersects with that AABB 2D. If there are no enemies left, then this is on and you can exit the level. I've got a lot of these like very small systems, like a couple of lines, or what are very vertical lines here. But you can see that this would be maybe one line in somebody else's editor. This is what it looks like inside of Blender. Here's that arch that I was talking about. There's a number of scenes in here, one for each of the enemies. So like the flock sphere is what I called it, is set up like this. There's a bunch of materials that are just textures from Substance Painter here. Couple things I didn't end up using, like this coin. Couple of the levels are also in here. The text here is just mesh. So this is, for the first level, I remeshed it myself. For the second and third levels, you can see that the meshing is quite a bit uglier, but I don't have a lot of the text, so I didn't really consider that to be all that much of an issue. It is what it is. We've also got the player in here. The player has that animation stuff on it. It's all rigged in here as well. You can see this is one of the animations. This is the hammer slam. I've got a couple of actions in here. So this is idle and that's a hammer slam. A couple of data blocks. One of the things that I want to be able to do moving forward is we have those animation events that are firing that we add as we translate from asset loading to playing. We can add markers inside of Blender, and I can name these something like hammer slam, right? So if these are named in a certain way, then we will be able to map them to marker components or events using reflection, and thus this can be an event that fires at frame 8 effectively, which is much nicer. There's a little bit of work that needs to happen before that is possible to do, including an upstream change to Bevy to be able to access the animation clips in the extension handler, but hoping to get that in at some point. There's also a couple of utility meshes in here. So this is a cylinder with no top and no bottom, laid out with UVs in a specific way so that I can go from 0 to 1 on the y-axis. This is one of these spawning containers. So we're back in the first level. If we go to the second, then we can see this spawn action that comes in here. The flames that come up are on that cylinder or on a couple of those cylinders. And this is that cylinder with a custom material on it. Speaking of those effects are probably my favorite part of the work that I did this week. I did a short on the channel explaining this in a little bit more detail, so you can go check that out if you want to. But the effect is basically this one texture as a plane on the ground, using UVs to rotate different channels in different directions. And then the column is significantly simpler, which is just some Perlin noise applied to the UVs in certain ways. Similarly, if we talk about the health bars, and I zoom in a little bit here with the projection using Bevy Inspector eGUI, you can see that the health bar here actually does have like a lerp effect. So there's like chunking damage that then lerps down to the actual damage count. And those are also using shaders with some vertex and fragment aspects to it. All of the effects are handwritten. I didn't use Hanabi. I didn't use any other tools to do this. They're just planes with images that I authored and effects that I wrote and UVs that I mapped and so on and so forth. So I'm pretty happy with the effects overall. Let's see, we talked about the animation extension. The controls aren't super interesting, pretty basic usage of Bevy enhanced input. Right now, I think there's a bug with smooth nudge that makes it frame rate dependent, which is unfortunate. So I am immediately after this video going to switch to using delta scale, which doesn't have that bug currently. I'm also very happy with the way that I set up the arbitrary spawning of a bunch of different entities. So we have crystals, flock spheres, and the eyes. And the way these are all pretty much set up is I built a custom app extension trait where you can give it an ID as well as a spawn system. These spawn systems are in each of the individual modules and define sort of where this thing should spawn, how it should spawn. In this case, the spawn for the eye is pretty simple, but the spawn in animations are all generic. So there's a file here called spawn systems with the app extension trait that is register spawn system. This grabs some stuff from the world, registers the system, gets the system ID back, registers that ID with a resource that I can access later. And this means that I can spawn any entity arbitrarily using the same like circle, column, Perlin noise configurable setup, because the timers for setting all of those things up eventually trigger a system by system ID. This is also nice because things like scaling in or translate up in or any of these like entrance effects are all componentized and have their own timers and things like that. So you can see in all of these systems, I have a timer. I'm ticking that timer with the delta time, checking to see if it finished. If it finished, do one thing. If it didn't, continue the effect. I'm using curves for some of these things, which is really nice because it means that everything isn't linear. And if we look at the way that these enemies get basically inserted, this is our spawn and enemies system, which fires basically whenever we need to spawn a new level's worth of enemies. Bevy Jam gives us access to this RNG, which I found really useful. It's nice to just have this RNG rather than have to think about how to create a threaded RNG or anything like that. We grabbed the current nav mesh and some stuff like that, as well as the spawn systems that we were just talking about, which is a resource, a hash map from basically a string ID to a system ID. We're using Bevy Jam's RNG to grab the navigation mesh, throw that into Bevy's uniform mesh sampler, and then sample arbitrary positions inside of that mesh, which we then make sure are actually inside of the nav mesh that we didn't mess up. If it is inside of that nav mesh, I use the RNG again to pick one of these three. So Flock Sphere, or Gemrock. I grab the appropriate spawn system from that resource, and we init the spawn circle. So this is what I mean by the spawning is generic and configurable. The position has to be given here for where the spawn is going to happen. The event is just a system ID, so it's going to call some spawn system at some point in the future. This is the system that will get called. And then here I'm just configuring it with a spawn color, but we could do any other configuration as well. So the Gemrock gets a blue spawn circle, and everything else gets red. A init spawn circle then is a custom command. So we can put any kind of configuration we want in here. This makes sure that the relevant things are loaded, kicks off some timers, and then spawns in that spawn circle with some timers to trigger the sequence of events that does the actual spawn circle, the cylinders with the noise, as well as the actual end trigger. So we store that system ID in this component, which is a system ID that takes a transform and spawns something. And here's our spawn circle system, which again takes time and the timers, ticks the timers, and if it's time to spawn something, runs a system with the appropriate transform to give it that location that it should now spawn at. So we have the super generic spawning system for any entity, which I'm pretty happy with. This is, I do have to say, kind of it almost feels like a replacement for BSN, which is Bevy scene notation, which is going to be coming at some point. So it'll be interesting to see how this changes when that lands. And then I think the only other thing that I feel like talking about is the health bar setup. So we have these like world space health bars, which have some adjustments in a vertex shader as well as a rendering in a fragment shader. We've got a couple of systems to update different health values and stuff like that. A couple of observers to handle when an attack happens, how do we deal damage, how do we put that into the health, as well as on-add health. On-add health takes that health component, which I should probably talk about first. So there's a health component. That takes the total amount of health an enemy can have, the sort of last value that health was at. So if it's being initialized for the first time, last and total are the same. Current is also the same. So we end up with this is the total that the entity can have. This is the last value we had, and this is the current value. And we basically lerp from last to current for that damage chunking behavior. We also have a health bar display relationship. So when you spawn any entity, if we go back to say eyes, all you need to do to trigger this behavior is insert the health component when you're spawning in whatever you're spawning. And then when that health component is added, this is an observer, we also spawn a rectangle with an arbitrary size, the health bar material with some default values, as well as a relationship that determines what entity this health bar is related to. Now, I think moving forward, this is going to be an entirely GPU-driven system, but for now, we are actually spawning in effectively a separate mesh for every health bar. This health bar does have a custom vertex shader that does some positioning. In this case, it basically just kind of moves it up a little bit. And then some pretty straightforward rendering in the fragment shader. And overall, I'm pretty happy with this. I'm generally happy with the API, which only requires that you add the health component in the first place. And then these relationships just get automatically set up. But there are some things that I need to do. Like the player's health shouldn't necessarily be shown above them. It should be shown in like the actual UI. You'll notice there's no start menu in the entire game and things like that, just because I didn't get to things. I am a single developer, and I did some. My goal with this jam was to make sure that the things that I started, I finished. So I started with some of those VFX, and I started with some of those spawn systems, and thus those things are the most built out parts of this game. Whereas the player, as you can tell from this face here, didn't get a lot of texturing time. It also didn't get, I don't think there's any textures on the hammer. I think I just forgot. And the animations here are not what I would consider super engaging animation. There's not a lot of like if you're going to swing a hammer like this, you probably have to move your hips, right? There's none of that, et cetera, et cetera. So there's plenty of things that I would change and do better, but I think I'm generally happy with things like the spawning capabilities, things like the usage of Blender to do different things like the animations. I have some good points to build on top of. There obviously needs to be like more character control here. These towers originally were supposed to be like protecting the little enemies that ran around, but I didn't get to that either. The lasers that this thing is shooting out shouldn't be gizmos. That is just literally a red gizmo line. Which is fine, but is not, not anything that I'm super proud of either. I'm most proud of these entrance spawns and the way that they are super generic across any of them. The fact that I can now go in and just drop in a bunch of different variations here, different colors, different textures, different things like that. I think this is in a place where I want to continue working on it. I am debating whether to upgrade this to 0.19 basically immediately, or to keep it on 0.18 and work on more different mechanics and stuff. I think I want to upgrade it to 0.19 so that I can do some of the animation clip events kind of work that I want to do, which would help Bevy Skeen for, 0.19's version and stuff like that. So that's it. All the code is on GitHub. I will post a link in the description. The code, I haven't decided if I'm going to update that repo moving forward. It probably won't get updated for the next 12 days because jam voting is happening. I'm releasing this video earlier because I really don't think this is going to this is not going to win any jams, so to speak. I think that some of the effects, some of the shaders and stuff and the spawn effects are cool, but this is not probably not winning any jams anytime soon. So I'm not really worried about it. But there are things I'm happy with, things that I really didn't get to. I didn't get to the audio at all. So for example, my jam rating for the audio is going to be 0. Audio would help a lot. Audio gives a lot, even for this very basic hammer. If the hammer gave off a big thonk, that would add so much just to the hammer. But that's really it. I am happy to take questions in the comments if you have questions around any of the implementation, any of the tools that I used or whatnot. I did use Substance Painter to do the texturing on these elements. I used Blender to do all the modeling, rigging, animation, stuff like that. I used Skeen to insert the components, and then I just wrote a bunch of Bevy code, custom shaders, stuff like that. So yeah, if you have any questions, leave them in the comments, and I will see you in the next one.